This is question 8 from the CCEA A2 Pure paper from the summer 2022, sort of differential equation one. So let's take a wee look. Ambient temperature of a restaurant remains constant at 20 degrees C. Theta is the temperature of the food T minutes after leaving the kitchen, and the rate of change can be modelled by the following differential equation. Given that the food leaves the kitchen with a temperature of 140, find theta in terms of K and T. So we have this here and we want to separate it out. So we're going to go 1 over theta minus 20 d theta equals minus K dt. I hope you can see what I've done there. I've taken everything with a theta and the d theta over to this side, everything with a t and the dt over here, and I've kept the k over here. You could bring it back down there. It's just a little bit more convenient, I think, if we do that. So we're going to integrate both sides here. Integrating this with respect to theta. This is an ln one. If I differentiate the theta, I get a 1. So I would have that. So that just goes straight into ln theta minus 20. And then here we get minus kt plus c. So we can do this a couple of different ways. Given that the food, find theta in terms of k and t. So we need to try and get the theta on its own here. So we're going to go theta minus 20 equals e to the minus kt plus c. And hopefully you've seen this sort of thing before, but you can kind of rewrite this as e to the minus kt times by e to the c, and we're kind of letting then e to the c equal a. So it means theta minus 20 is a e to the minus kt, where a can be worked out. So food leaves the kitchen with a temperature of 140. That means whenever t is 0, theta is 140. So we do 140, take away 20. We get 120 equals a e, and again that's going to be 0. So that gives us a then is 120. So that's our equation really. Then we're going to go theta minus 20 is 120 e to the minus kt, and it says to get theta in terms of k and t. So I have theta equals 120 e to the minus kt plus 20. On then to part 2. A food critic visiting the restaurant notes that it takes 2 minutes for her food to arrive and records a temperature of 75 degrees C. Andrew is a chef in the restaurant. He believes that the food from his kitchen should be served to customers at a temperature of at least 60 degrees C. Find the time in which a waiter must have delivered the food in order to meet the chef's requirement. Give your answer in minutes and seconds to the nearest second. Right, goodness me. So whenever it's 2 minutes, T is 2, the temperature is 75. So we can use that then to work out our K. So our formula then, as you know, is going to be theta equals 120 e to the minus kt plus 20. And as I say, we know whenever t is 2, then theta is 75. So that means 75 equals 120 e to the minus 2k plus 20. And we can, I guess, substitute that in and rearrange it. So let's see what we have. Our t is that. So 55 over 120 is e to the minus 2k. So I think it's going to be then ln 55 over 120 equals minus 2k. And I think if you put that into your calculator, let's see. Sorry, I need to try and find my calculator here. Yeah, that works. So I have k then equals minus a half ln 55 over 120, and that then is approximately equal to 0.3901. So my formula then becomes theta equals 120 e to the minus 0.3901 t plus 20. So what are we asked? We're asked then whenever it has to be less than or equal to 60. So we're going to have this as less than or equal to 60. Sorry, it's greater than or equal to 60. Of course it is. Because you want the temperature to be greater than or equal to 60. Now some people just put a wee equal sign in there and then just sort of work it out from there, but that's fine. So we're going to have then e to minus 0.3901 t is greater than or equal to, that becomes a 40, and then divide by 120, so that then is going to become a third. Again, if you put that in your calculator, you're going to take logs of both sides, so ln a third and divide by 0.391. You have to get t is less than or equal to 2.816 minutes, and then you convert that to seconds, and it's going to be 2, so it's 0.816 I guess times 60 will give you then 49, so it's 2 minutes 49 seconds.